Welcome back. Today we're going to be talking about angles of depression. So angles of depression. An angle of depression is the angle between the line of sight, so just like yesterday, it's our line of sight when the observer looks down, and the horizontal. Okay, so this time I'm up here on a cliff and I see a boat. So from where my eye level is down to the boat, that's our line of sight, and then the horizontal. This is our horizontal, so our angle of depression is right here. Okay, it's between those two lines. Alright, so let's do a few examples with this one. So the tailgate of a moving van is 3.5 feet above the ground. A loading ramp is attached to the rear of the van at an incline of 10 degrees. Find the length of the ramp to the nearest 10th foot. Okay, so what does our picture look like? So we've got the back of our moving van, and we have this tailgate sticking out here. Okay, and then we're going to attach a ramp to it. Alright, so here's our tailgate. We've got a ramp attached to it, so here's our ramp. There's the ground. There's our 90-degree angle there. And then here's our horizontal. Okay, so it says it's at, moving van is 3.5 feet above the ground, so this is 3.5. And then it tells us the loading ramp is attached to the rear of the van at an incline of 10 degrees. That means this piece right here is 10 degrees. Okay. Alright, so we're going to find the length of the ramp to the nearest foot. That means we want the hypotenuse. We want x. Okay, so we can do this a couple different ways. So we're going to go through both of those. So the first one is going to be using our parallel lines. We know this is horizontal, we also know this is horizontal. So if we have two parallel lines cut by a transversal, we know our alternate interiors are going to be congruent. So this angle down here is also 10. Okay? So we're going to approach it with this first. So from 10, we have an opposite and we have a hypotenuse. So opposite over hypotenuse, we're dealing with sine of 10 degrees. And that's going to be 3.5 over our x. Okay, 3.5 over the x. So then in order to solve for x, we've got to get rid of that x in the denominator, so we're going to multiply by x on both sides. So we end up with x sine of 10 equals 3.5. We still need x by itself, so we're going to divide by sine of 10. Okay, so we end up with x equals 3.5 over sine of 10. So we're going to punch that into our calculator. So we have 3.5 divided by, we're going to go to our trig functions, sine, and then 10, and we end up with 20.1557. So we're going to go to the nearest tenth again. So that would be 20.2. So approximately 20.2. Okay? And that would be feet. Our label is feet here. Okay? So I said there's two ways to do this, so let's look at the second way. So we're going to use this same picture, but instead of using the 10, I'm actually going to use this angle up here. Okay, so I'm going to redraw my picture. Instead of using the 10 that's here, I'm going to use this angle down here. If this is 10, what is this? Well, the whole thing is 90 degrees, so I know this angle has to be 80. This is still my 3.5, and this one is still x. But I'm going to be using adjacent over hypotenuse this time. So that's going to be cosine of 80 equals adjacent, which is 3.5, over hypotenuse, which is x. So the same steps here. We're going to multiply by x to get it out of the denominator. And then we are going to be dividing by the cosine of 80. So x cosine of 80 equals 3.5, and then dividing by cosine of 80, dividing by cosine of 80 on both sides. So these cross out, we're left with x equals, we're going to punch it into our calculator again. We have 3.5 divided by, this time we have cosine of 80, and hit enter, and we come up with the exact same answer, which is 20.2. And then that's feet as well. And that is an approximate answer. So it doesn't matter which way you do it. You could use sine or cosine, you're still going to come up with the exact same answer. Alright, let's do another one. So we have another word problem here. We have Olivia. She's in a lighthouse on a cliff. She observes two sailboats due east of the lighthouse. The angle of depression to the two boats are 33 degrees and 57 degrees. We're going to find the distance between the two sailboats to the nearest foot. Okay, so our picture. We're up on a cliff. Okay, so we've got our cliff here, and we have a lighthouse on top of the cliff. Okay, so I've got my little lighthouse, and I have two boats. Two boats out here in the water. So from the lighthouse to one boat, and the lighthouse to the other boat, it told us we have, let's see here, what does it say? Due east of the lighthouse, the angle of depression to the two boats are 33 and 57. So we've got to go straight out from our lighthouse. So we have this angle is 33, and this bigger one is 57. Okay? Alright. I'm going to go ahead and finish my triangles here. So now we have our right triangles. Let's see, what else does it tell us? Distance. Okay, so the cliff. The cliff is 110 feet. We're going to label some more pieces here. 110 feet. The lighthouse is 85 feet. Okay, that's 85 feet. 110 and 85. Alright, and it wants to know the distance between these two boats. Okay, so we really need to figure out the distance from the cliff to the boats. The cliff to the boats on both of these. So we're trying to find x, y, and we'll call this whole thing z. Okay? Alright, so just like we did on the other one, you can do this two ways. You can either work with the 33 and the 57, or you can do these angles inside here. I'm actually just going to transfer with our parallel lines so that I'm working with these angles down here. So this one is going to be from here, so that's my 57, and this one is going to be my 33. Okay? Alright, so working with my 57 first, I've got an opposite and I've got an adjacent. So I'm working with tangent. So tangent of 57 equals my opposite. This entire thing would be 195 because I have to take my 110 plus my 85. So 195 That's my opposite. My adjacent is x. Okay? So if you notice, this looks just like the one that we got done doing on the first example. So multiplying by x, multiplying by x. So we end up with x tangent of 57 equals 195. And then divide by tangent of 57 on both sides. So x is approximately, get our calculator out, 195 divided by trig functions. We're going over to tangent, and then 57. I get 126.634. And so let's go 2 decimal places on this one, since we're not done rounding here yet. 26.63, because we still have to find our final answer of y. Okay? So from here, let me scoot this up just a little bit. So from here, now I'm going to be working with z, because I'm going to do the 33. So the same thing. Tangent of the 33 equals opposite, which we said was 195, over adjacent, which is z. Okay, so we're going to get z out of the denominator, so we're going to multiply it by both sides. Then from here, we have z tangent of 33 equals 195. Divide by our tangent of 33. So we get z by itself. So on our calculator, we're going to do 195 divided by trig functions. We're going to go to tangent again. Tangent, this time it's 33. And I get 300.274. So z equals 300 decimal, let's go 2 places again, that's 27. So then from here, if z is 300.27 and we know x is 126.63, how do I find y? I'm going to take 300.27 minus my x, which is 126.63, and that's going to give me my y. That's what's left over. Here's the whole thing minus this piece is going to give me what's left over. So 300.27 minus our 126.63, I'm coming up with 173.64 equals y. It says to the nearest foot, so we're going to round that to 174 feet equals our y. Okay, so that would be our final answer. The distance between the two boats is 174 feet. Okay, great. That's all for today. I'll see you in class tomorrow. Bye.